All right. Welcome back, everyone, to another deep dive. This time, we are tackling Heinrich Hertz.
Ooh, a good one.
Yeah, a name you definitely know. I mean, who hasn't heard of Hertz?
Yeah, the unit of frequency.
Right, exactly. But I gotta ask, how much do you really know about the man behind the unit? Like, beyond just that basic fact.
Yeah, good point.
Well, get ready.
Yeah.
Because in this deep dive, we're going to uncover the story of Heinrich Hertz. And honestly, it's a lot more interesting than just a unit of measurement, that's for sure. We're working with some excerpts from a Hertz biography today.
This is good.
And trust me, you are going to be surprised by some of this stuff.
I'm intrigued.
So to kick things off, let's rewind the clock all the way back to 1857, the year Hertz was born in Hamburg, Germany.
Okay.
Now his family wasn't just any Hamburg family, they were Hanseatic.
Hanseatic.
Yeah, Hanseatic.
I'm not familiar with that one.
Yeah, I had to look it up too. It basically means they were descended from members of the Hanseatic League, which was this super powerful medieval trading alliance. Yeah. So basically, Hertz came from a family that was really steeped in commerce and cultural exchange.
That's interesting.
Yeah.
You know, it makes you think about how that kind of environment might have shaped his worldview,
Yeah, for sure.
even his approach to science, potentially.
Absolutely. I mean, just think about it. Growing up surrounded by that kind of environment, it must have instilled a sense of curiosity in him
Right.
about the world and how everything is interconnected.
Yeah, I see that.
And speaking of interconnectedness, Hertz wasn't just a science guy.
Oh.
Yeah, he was actually really good at languages too. Like, really good.
Huh.
He even learned Arabic.
Wow, that's impressive.
Right. Talk about a well-rounded individual.
It speaks to his mind, like a mind that's both analytical, but also open to different ways of thinking.
Yeah, I get that.
That kind of intellectual flexibility, I think it can be a real asset in scientific discovery.
I totally agree. And this diverse skill set, it really shines through when you look at his education. He studied in Dresden, Munich, Berlin, learning from, like, the biggest names in physics.
Oh, wow.
Yeah. Kirchhoff, Helmholtz, these guys were giants in their fields.
Oh, yeah, I know those names. Kirchhoff's laws. That's like
Yes.
Circuit Theory 101.
Exactly.
And Helmholtz. I mean, he made major contributions to optics, acoustics, so much.
Yeah, it's incredible. Imagine being Hertz, getting to learn from these guys.
Yeah, that must have been pretty influential.
Right, like getting a master class from the rock stars of physics. You can almost picture those classroom discussions, sparking his own ambitions to make some big scientific discoveries.
Oh, I can see that.
And that brings us to a pretty pivotal moment in Hertz's career. The year is 1879, and Helmholtz presents him with a challenge. A daunting challenge, I should say.
Uh-oh.
He asks Hertz to prove Maxwell's theory of electromagnetism.
Whoa, okay.
Yeah, this was a huge ask.
Yeah, I can imagine. I mean, Maxwell's theory, that was revolutionary stuff.
Oh, absolutely.
It suggested that these invisible waves, electromagnetic waves, they could travel through space, and that even light itself was a form of these waves.
It's mind-blowing.
It really is.
Yeah.
But the thing is, at that time, there was no experimental proof.
Right. It was just a really bold idea that needed someone to come along and actually validate it.
Totally.
So picture this. You've got Hertz, who's still relatively early in his career,
Mm-hmm.
and he's suddenly faced with this monumental task of proving a theory that could completely redefine our understanding of physics.
Yeah, I can see how that'd be a bit intimidating.
So what was his initial reaction?
Well, he was hesitant, actually.
Understandably so.
Yeah, I mean, it was a massive undertaking.
Yeah.
So he actually ended up shifting his focus for a bit to
Uh-huh.
other areas of research within electromagnetism.
Interesting.
But here's the thing. This wasn't time wasted. He used this period to really dive deep into Maxwell's work,
Oh, okay.
to strengthen his own grasp of the concepts.
Gotcha.
So in a way, it was like he was laying the groundwork for his eventual breakthrough.
That's a good point. Like, he was absorbing all this knowledge, letting it simmer, and waiting for the right moment to put it all together.
Exactly.
And that moment arrived in 1886, while he was a professor at Karlsruhe, experimenting with these things called Reese spirals.
Reese spirals? What are those?
They're basically these coiled wires,
Mhm.
early inductors, essentially. You know, crucial components in electrical circuits.
Okay, I'm following.
But here's the interesting part. Hertz wasn't using them in a way that was directly related to proving Maxwell's theory. He was just exploring different aspects of electromagnetism.
Huh.
So this wasn't like a planned step-by-step experiment to go and validate Maxwell's ideas.
I see.
There's an element of serendipity here.
Right, yeah, totally.
And that's where things get really interesting. So Hertz is working with these Reese spirals, and a Leyden jar, which, by the way, is basically an early form of a capacitor.
Okay.
And he notices something strange. He sees a spark in one coil.
Yeah.
When the Leyden jar discharges into another nearby coil.
A spark?
Yeah. Now, I'm guessing that most people would have just been like, huh, weird, and moved on.
Right, just a fluke.
Exactly. But Hertz, with all his knowledge of electromagnetism, he saw something more in that spark.
What do you mean?
Well, that seemingly insignificant spark, it triggered a cascade of thoughts in his mind.
Interesting.
And that's what led him to the idea for an apparatus that could generate and detect electromagnetic waves.
Oh, wow.
Yeah. So this accidental observation became the catalyst for him to finally tackle Helmholtz's challenge head-on.
That's amazing.
Isn't that cool?
Yeah, talk about a eureka moment.
Right. This random spark leads to a scientific revolution.
It makes you wonder how many other breakthroughs are out there, just waiting for someone to connect the dots.
Absolutely. So now the question is, what did this groundbreaking apparatus actually look like?
Yeah, good question. Well, it was actually surprisingly simple,
Yeah.
but ingenious in its design.
Mm.
Hertz used a dipole antenna, basically 2 wires with a spark gap in the middle. And then he added these zinc spheres at the ends to increase the capacitance. And this was his transmitter.
So how'd he create the spark? I mean, it's not like he had a battery pack handy.
Right, good point. He used something called a Ruhmkorff coil, which was this device capable of producing high-voltage pulses. And those pulses created the spark across the gap in the dipole antenna.
Makes sense. But, okay, so he's generating these sparks. How does he know if they're actually producing those invisible waves that Maxwell theorized about?
Well, that's where the receiver comes in. It was another loop of wire. But this one had a tiny spark gap. And if electromagnetic waves hit the receiver, a tiny spark would jump across that gap.
Oh, clever.
It was a brilliantly simple way to detect the presence of these invisible waves.
So essentially, he built the first radio transmitter and receiver.
Pretty much.
All thanks to a chance observation with some coils in a jar?
It's amazing what a curious mind can do.
It really is.
It's that kind of insight that sets the great scientific minds apart.
Yeah, I agree.
It's not just about knowledge, you know. It's about seeing the world in a different way, connecting things that other people might not even think to connect.
I like that. So here we are. Hertz has his setup. He's got Maxwell's theory in his head. It's time to put it all to the test.
This is where it gets exciting.
What happens next?
What happens next is amazing. Hertz conducts this series of experiments, super meticulously designed. And they don't just validate Maxwell's theory. They actually reveal the true nature of these waves, these electromagnetic waves.
Yeah, he didn't just want to prove they existed.
Exactly.
He wanted to understand, like, everything about them, how they behave, their properties, all that.
He was meticulous for sure, always going deeper beyond the surface level.
So what did he find out? What were some of the big discoveries that came out of these experiments?
Well, first and foremost, he confirmed that these waves, they actually did exist, like for real.
Incredible.
Yeah, he was able to generate and detect them, what we now call radio waves, a specific type of electromagnetic wave.
A monumental discovery.
Oh, absolutely. It fundamentally changed our understanding of the universe.
I mean, think about it. These invisible waves, predicted by Maxwell, but never actually observed before?
Right.
And now suddenly, they're demonstrably real.
It's mind-blowing.
Totally. So what else did he learn about them?
Well, he didn't stop at just proving they existed. He actually went on to measure their speed.
Okay.
And guess what?
What?
He found that they traveled at the speed of light.
Whoa, seriously?
Yeah, and this was a huge piece of the puzzle because remember, Maxwell had theorized that light itself was an electromagnetic wave.
Right.
And Hertz's findings,
Yeah.
they provided the first experimental evidence to support that claim.
So not only did he confirm that these waves exist, but he showed that they travel at the speed of light.
Exactly.
Which gives even more support to Maxwell's theory.
Oh, totally.
Light was no longer this mysterious phenomenon,
Right.
but part of this larger electromagnetic spectrum.
Huge conceptual leap.
Absolutely.
But it doesn't stop there. Hertz kept going, investigating other properties of these waves.
Yeah. Like what?
Well, he demonstrated that they could be reflected, refracted, and even polarized, just like light.
Hold on. I think we need a quick refresher here for those who might not remember what all those terms mean.
Yeah, good point. Okay, so think about how light behaves. Reflection is when light bounces off a surface, like a mirror.
Right.
Refraction is when light bends as it passes from one medium to another, like when a straw looks broken in a glass of water.
Okay, yeah. And what about polarization?
Polarization is essentially filtering light so that its waves only vibrate in one direction, like Polarized sunglasses reduce glare by blocking certain light waves.
Ah, okay. So Hertz showed that these invisible radio waves, they acted just like light,
Precisely.
even though you couldn't see them,
Yeah, it's like he was revealing their hidden identity.
showing they weren't that different from the light we see every day.
Exactly. And these findings, they had a huge impact on the scientific community. They provided that concrete experimental validation. For Maxwell's theory,
Yeah.
revolutionized our understanding of electromagnetism.
It's incredible.
But what's even more remarkable is that these discoveries laid the foundation for so many technologies. Technologies that would come to define the 20th century and beyond.
Like what?
I'm talking radio, television, wireless communication. All of it stems from Hertz's work.
It's hard to believe that these experiments, conducted over a century ago, would have such far-reaching consequences.
I know, right?
So how did Hertz react to all of this? Was he out there, like, proclaiming a new era of technology?
Well, not exactly. This is where we see Hertz's humility. He actually saw his discovery as purely theoretical.
Really?
He even said that it was of no use whatsoever.
No use.
Yeah. Can you imagine the man who unlocked the secrets of radio waves, thinking they were useless?
It's wild to think about that, knowing how essential wireless technology is to us now.
It really is. Makes you wonder, what scientific discoveries today that seem useless might actually revolutionize our future?
Yeah, that's a great point. You never know.
Exactly. It just underscores how unpredictable scientific progress can be. But you know what else is fascinating? Hertz made other contributions too, often overshadowed by his radio wave discoveries, but equally profound.
Oh, yeah. Like what?
Well, for instance, he did some pioneering work on cathode rays.
Cathode rays. Remind me what those are again.
They're streams of electrons emitted from a cathode in a vacuum tube.
Oh, right. Right.
And while some of his conclusions about cathode rays were later revised, his research actually laid the groundwork for future breakthroughs.
Like what?
Well, one big one, the discovery of X-rays.
Wow. So even when he wasn't totally right, his work still led to incredible advancements.
Yeah, it's like he was shining a light on these new avenues of research.
Inviting others to follow his lead?
Exactly. And his contributions didn't stop there. He also made some important observations about the photoelectric effect.
The photoelectric effect.
Yeah, it's when light shines on certain materials.
Yeah.
And causes them to emit electrons.
Right.
His work in this area was crucial for our understanding of how light and matter interact. In fact, his observations later helped Einstein develop his theory of the photoelectric effect.
Wow.
Which, won him a Nobel Prize.
So Hertz indirectly contributed to a Nobel Prize-winning discovery.
Pretty amazing, huh?
Yeah, that's incredible.
And then on top of all that, his curiosity led him to explore a field called contact mechanics.
Contact mechanics.
It might not sound as exciting as radio waves, I know.
Right.
But it's super important for understanding how solid objects behave when they come into contact with each other.
Okay.
Like, think about how tires grip the road or how gears mesh together.
Got it.
Hertz developed a theory to describe the stresses and deformations that happen at those contact points. And it's still used today in fields like engineering and material science.
Wow, that's pretty amazing. His work spans such a huge range of areas.
I know, it's impressive. From the subatomic world of electrons to the mechanics of everyday objects.
A true testament to his versatility.
Absolutely.
Yeah.
But sadly, his career was cut short. He died at the young age of 36.
Oh, wow. I didn't realize he died so young.
It makes you wonder what else he could have accomplished if he had more time.
Yeah, it's bittersweet, knowing how much he achieved in such a short lifespan.
But his legacy lives on, not just in the Hertz unit that we all know,
Yeah.
but also in the countless institutions, awards, even a crater on the moon named after him.
It's amazing.
A fitting tribute to a man whose work continues to shape our world.
Absolutely. So let me ask you this. If Hertz could see how his useless discovery, those radio waves he thought had no use, if he could see how they shaped our world today,
That's a good question.
what do you think he would say?
That's a tough one. It's hard to say for sure, but I imagine he'd be astonished, definitely. Maybe even a little amused, honestly, at the irony of it all.
Yeah.
Like, here's this guy who thought radio waves were useless, and now they're connecting billions of people around the world.
It's pretty incredible.
I bet he'd be more fascinated by the scientific progress itself. How his discoveries led to new avenues of research.
Than the actual technological applications, which makes sense given his personality.
Yeah, he was known for his humility, his focus on knowledge for its own sake.
Makes you wonder, though, what would he think about our modern world shaped so heavily by those useless waves.
It's a mind-boggling thought. And it really highlights how we can't always predict the impact of scientific breakthroughs.
Absolutely. Sometimes the most profound discoveries come from the most unexpected places.
Right.
A blend of meticulous research and happy accidents.
Serendipity.
Exactly. Which brings us back to our big question. Who was Heinrich Hertz? Beyond just the unit of measurement.
Well, he was a true visionary, a meticulous experimenter, and a humble seeker of truth.
I like that.
His legacy isn't just about his discoveries, but about how he approached science itself, with rigor, curiosity, and a willingness to embrace the unknown.
Beautifully said. He wasn't driven by fame or fortune, but by this deep desire to understand the universe.
And in doing so, he changed the world.
It's inspiring, honestly.
It really is.
So I hope this deep dive has given you a new appreciation for Heinrich Hertz.
More than just a name on a unit.
Exactly. He helped unlock some of the universe's deepest secrets.
And his story. It's a reminder of the power of curiosity.
And the unpredictable nature of discovery.
If you're interested in learning more about Hertz, we'll be sure to include some links in the show notes.
Absolutely. And who knows, maybe this deep dive will spark some new curiosity in...
You never know where that spark might lead.
That's right. Until next time, keep those brains buzzing and never stop exploring.